Hey guys, so I was tutoring some people at PGH today and they were having some trouble with recursion and I just wanted to go over it. Um, but to really understand recursion, the first thing you have to do is understand stacks. And the way I want you to think of it is a stack of plates. And in the stack of plates, you really only have access to the top plate at any given time. So if the top plate is the yellow plate, you'll see that you can only access that top plate. The plates below that, you can't access them until you pop off that top plate. And you might think to yourself, hey, I've never used a stack before, but I disagree. Because there's something called a call stack underlying every programming language that sort of controls the order in which functions execute. And just to show you what I mean by that, we have a simple program here where the main function prints out start main and end main, but between them it calls foo. And foo prints out start foo and end foo, and in between it has bar. And bar, the bar function just prints out start bar and end bar. And down here we can see the output of this code. And what I'm trying to get at is we can use a stack to explain why the code is being output in this order: start main, start foo, start bar, end foo, end main. So let's try to do that. So first function that gets executed is the main function. So that gets put onto the stack. The main function prints out start main and then calls foo. Then foo gets put onto the stack, the call stack. Alright, we're going to call this the call stack. I mean, that's what it's called. We're not calling it that. Okay, so once foo gets put onto the call stack, it'll print out start foo. And then it'll call bar. So bar gets put onto the stack. In bar, we print out start bar and then end bar. So we have that here, start bar and end bar. Now that bar is finished, we can remove that from the stack. It gets popped off, and then control gets returned to foo. So now we're going to print out end foo, and then foo gets popped off the stack, and we return control to main, and main prints out end main. And then finally that gets popped off the stack. And what we've proved here is that the call stack is something underneath the hood that sort of controls how functions execute. And that's what recursion uses to do its magic. So let's talk about that. So I have another program here. It's a simple program. So this is something you should recognize. It has the similar structure to what we saw before. This is a function called recurse. It takes one variable n. It'll print out start recurse. It'll print out the value of n, and then it'll do a recursive call, n+1. And then it'll print out end recurse. So this is almost exactly like what we saw before. The difference is the difference is now we have this stuff up here, and this is called the basis case. Some people also call this the base case. Either way is fine. But what we're saying, if n is greater than or equal to 4, we just want to print that out and then return. No recursion, nothing. Just regular old code. And for recursion, you need both the base case and the recursive case. So this is the base case and this is the recursive case. And it's important to note, because if you don't have the base case, you end up with something like this, where it'll just keep recursing on forever and ever until something bad happens with the memory. In higher level languages, you have something called call stack limit exceeded error or exception. But in C++, it just sort of goes on forever until there's a problem with the memory. So base case, recursive case. So how do we explain this output? This is interesting. You have start, 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 end, end, end. But look at the behavior of n. It's going up, then it hits the base case, and then it's counting down. How is that happening? Well, I think let's just go through the code and see if we can figure out why that might be happening. So the very first thing that executes is main, is the main function. And once main executes, all it does is it calls the recurse function, right? So we can say recurse here, and it's passing in the variable n equals 1. So what does recurse do? Well, the base case is not satisfied, so it prints out start recurse, and then it calls itself again. So we have another recurse. But this time it's passing in n plus 1, which is 2. Then this n equals 2 recurse starts executing. The base case is not satisfied. It prints out this start statement, and then it calls itself again. So this is recurse with n equals 3. And oh, that's a funky 3. And then finally the same thing happens, and it calls itself again, this time with n equals 4. And now we hit the base case. So right, we print out n equals 3. Now we hit the base case. Print out n equals 4, we return, we're not adding anything onto the stack. So what happens now? Well, we pop off the stack. We pop this off the stack. We've printed what we needed to print. Control gets returned to the n equals 3. It prints out n equals 3. And this gets popped off the stack. Then it prints out n equals 2. Then this gets popped off the stack. Then it prints out n equals 1. And then this gets popped off the stack. And then finally, nothing else happens in main, so that's getting popped off the stack. So, we can go through the code execution and what it means, but really the two things we want to look at is that first, when you're building the stack, you're moving forward from the start. Forward from start. And after you hit the base case, if you have any code after the recursive call, this is moving backward from the end. Backward from the end. And this has a special name. It's called backtracking. Okay, and that's something you need to know. And the way it sort of happens is if you can sort of draw a line on line number 10 where the recursive call happens, and everything above is going in the forward direction, and everything below is backtracking. Tracking. So that's how I sort of want you to think about, backtracking in recursion. Okay, so now what we're going to do is, I have a little question for you, and this is a question that I got during a technical interview. Design an algorithm that returns the product of two integers a and b. Constraints are, the integer a is greater than or equal to 1. The integer b is greater than or equal to 1. You cannot use while loops, for loops, or do while loops, and you cannot use the asterisk symbol anywhere in your code. So try to do this on your own, and then when you're ready, I'll show you the answer. And so pause the video. 5, 4, 3, 2, 1. Solution time. Okay, so here's the answer. You should be able to look at this and figure out what's going on, but just in case, I'm going to sort of go through this problem in the same way that I did the other two. So let's see here. I'm going to need some room. White. Let's go through this. So what happens first? Well, the main function gets called. Right, so we have main. the main function calls product23. So now we're calling product, and the main function is passing in the variables a is equal to 2 and b is equal to 3. So that doesn't satisfy the base case of b equals 1, so product calls itself again. So at this point, hold on, product is calling itself again, and this time it's using a equals 2 and b equals b minus 1, so that would be 2. And product calls itself again, and now it passes in the variables a is equal to 2, b is equal to 1. And now we hit the base case. This is the base case. The base case is just sort of returns a. So it returns a. So it's going to return 2. So a is equal to 2. And then we pop it off the stack. Oh, can't do that. Let's just keep it there. It's fine. So we'll do an X. This pops off the stack. So the product that's returned is 2, and a is 2. We're in this function call now. So what is it going to return? 2 plus 2 is 4. So now it's returning a 4. So one stack below, this is now 4. This is 2. So 2 plus 4 is 6. And all the while we're popping these off the stack. Right? And finally main prints out 6, and then we're done. So the main point of this particular problem was I wanted to show you that you can pass information up the stack using parameters. You can pass information down the stack using the return statement. So that should give you a good idea of how recursion is working out. So at this point, let's blast through what we've done so far and do a quick review. So stacks are a last in, first out data structure, and that means the last plate you put onto the stack of plates is the first plate you're going to take off the stack of plates. There's something called the call stack that manages the function execution order, and that is a stack. Recursion uses the call stack to perform repetitive tasks, and you can use this instead of a loop or some iterative approach. So you can do repetitive tasks using recursion without using loops. Another thing you want to realize is that there's two parts to it. There's a base case and a recursive case. Recursive case has recursive function calls. Base case is just regular old code. In the recursive case, any code that comes before the recursive call is executed forward from the start, and anything that comes after the recursive call is executed backward from the end, and that's called backtracking. And finally, you can pass information up the stack using parameters, and you can pass information down the stack using return statements. You can also use things like global variables. That's totally in line with what you can do. So I hope this was helpful. If for some reason I went above your head and it's just not simple enough, or if it's too dense, I recommend this first video, a simple explanation of recursion by Code Basics. And this guy, his name is Dawal. I've actually met him in person. He's sort of the nicest, kindest individual I've ever met. He actually, this is like a work relationship, and he told me that if I ever come to New York, I can call him and he'll give me a place to stay. So, very cool guy and a very cool, very simple explanation. So if this was too simple for you and you want something way more comprehensive and you want something more towards mastery, it says recursion for beginners, but this guy is very, very comprehensive, and he's been teaching this subject for a while. So Recursion for Beginners, A Beginner's Guide to Recursion, is a great video. And so I've also done a video on Lab 1, Permutations of a String. So if you, it's a pretty extensive video, and I go through the algorithm, and we go through the execution and everything. So hopefully that'll help out. So the YouTube handle is buglabunda, and it's called Permutations of a String, Lab 1. Anyways, thank you guys very much. I'll include a link to all 3 of these videos down in the description. I really appreciate it. Bye-bye.